Think about the last time you tried to push something heavy. It didn't want to move. And once it did move, it didn't want to stop. That resistance feels obvious, almost intuitive. We usually say, it's heavy, or it takes more force. But here's the strange part. Even in empty space, with no friction, no air, and no surfaces pushing back, objects still resist changes in motion. They don't slow down on their own. They don't change direction willingly. Physics doesn't explain this resistance. By pointing to a force, it treats it as something deeper, a built-in property of matter itself. And once you realize that, a simple question becomes surprisingly hard to answer. Why should matter resist motion at all? The idea that objects resist motion feels so natural that we rarely stop to question it. When something is hard to push, we assume it's because it's heavy. When something is already moving fast, we feel how difficult it is to slow it down or turn it. Everyday language reinforces this intuition. We talk about effort, about strength, about things wanting to stay where they are. Your body learns this early. As a child, you discover that lighter objects respond quickly, while heavier ones demand more work. So your brain builds a simple rule. More resistance means more force is required. This rule works extremely well in the environments we live in. On Earth, motion is almost always tied to friction. Surfaces rub, air pushes back. Energy is constantly being drained away. In that world, motion feels temporary, and rest feels natural. If you stop pushing, things slow down. If you let go, they stop. So it's easy to believe that objects resist motion because something is actively holding them back. But notice something subtle. In all of these situations, there are interactions involved. The ground, the air, the surface you're pushing against. Your intuition quietly blends these effects together and attributes them to the object itself. The resistance feels like it belongs to the thing, but that feeling is shaped by environment, not by fundamental physics. Your brain is excellent at learning patterns that help you move safely and efficiently. It is not optimized to reveal how motion works when those everyday interactions are removed. And that's where the intuition starts to fail. Because when physics strips the environment away, no friction, no air, no contact force, the resistance doesn't disappear. It remains. And that's the moment where a familiar idea turns into a deeper mystery. Here's where the familiar explanation starts to fall apart. Imagine removing everything that usually gets in the way of motion. No air, no friction, no surfaces rubbing together, just an object drifting in empty space. Now give it a small push. Something surprising happens. The object doesn't slow down. It doesn't come to rest. It keeps moving forever, not because a force is still acting on it, but because nothing is stopping it. This already contradicts how motion feels in everyday life. On Earth, motion seems to require constant effort. Stop pushing, and things stop moving. But in empty space, the opposite is true. Motion doesn't need to be maintained. Only changes in motion do. Speeding something up, slowing it down, turning it. Those are the situations where force appears. So if resistance to motion were caused by force, it should disappear when forces disappear. But it doesn't. Even in a perfect vacuum, objects still resist changes in motion. They don't instantly accelerate. They don't instantly change direction. Push harder, and they change more. Push gently, and they change less. The resistance is still there, which means it can't be explained by friction, air, or contact. It's not something the environment is doing. It's something the object is doing. This is the first major shift. Physics doesn't say objects resist motion because forces oppose them. It says objects resist changes in motion because that's how matter behaves. Force doesn't create motion. Force changes motion. And how much an object's motion changes depends on a property it already has. A property that doesn't come from interaction, but exists even when the object is completely alone. At this point, we usually introduce a name. But before we do, it's worth sitting with the idea. There is something about matter that makes motion reluctant to change, not because of what surrounds it, but because of what it is. Let's stay in that empty universe for a moment. No air, no friction, no surfaces pushing back, just an object floating in space. You give it a gentle push. Immediately, it starts moving. And then something remarkable happens. Nothing else happens. It doesn't slow down. It doesn't speed up. It doesn't curve or drift. It simply keeps going. Now imagine giving it another push, this time from the side. Its motion changes. Not instantly, not all at once, but in proportion to how hard you push, the object responds smoothly. This tells us something important. The object isn't resisting motion itself. It's resisting change. Moving at a constant speed is not something the universe needs to explain. Changing that speed is. So now try a different scenario. Imagine two objects in empty space. One is light, the other is heavy. You push both with the same force. The lighter one responds quickly. The heavier one responds slowly. Nothing is holding either object back. There is no friction to blame. Yet the difference remains. The resistance is built into the objects themselves. At this point, we usually say the heavier object has more inertia. But that word can hide the mystery. What it really means is this. The object's motion has a kind of persistence. It doesn't want to be changed. Not in a psychological sense, and not because it has intentions, but because motion, once established, is something matter naturally maintains. This persistence doesn't need a cause. It doesn't come from outside. It's simply how matter behaves when nothing interferes. And that flips our usual picture. Instead of asking, what keeps things moving? Physics asks, what causes motion to change? In everyday life, we experience constant interference, friction, collisions, contact force. These effects mask the deeper rule. They make it seem like motion is fragile and rest is stable. But in empty space, the opposite is true. Motion is stable. Rest is just motion, described from a convenient point of view. Once you see this, the resistance objects show starts to feel less like an obstacle and more like a fundamental feature. Matter doesn't need to be told to keep moving. It only needs a reason to stop or turn. And that realization leads directly to the idea we're circling around. At this point, it helps to finally name what we're describing. Physics calls it inertia, but inertia isn't a force, and it isn't something objects generate. It's a property, a way matter responds. When you try to change its motion, an object with more inertia doesn't resist motion because it's being held back. It resists because changing its motion requires more influence. This is why mass matters. Mass is not just about weight. Weight depends on gravity. Mass does not. Mass tells you how strongly an object resists, changes in its state of motion. Push a light object, and its motion changes easily. Push a massive object, and its motion changes reluctantly. Not because something is fighting you, but because the object's inertia is larger. What's important here is that physics does not explain inertia by pointing to anything deeper. It doesn't say inertia is caused by friction or by forces acting inside the object. It treats inertia as fundamental. That might sound unsatisfying. We're used to explanations where everything has a cause. But in physics, some properties are taken as basic. Charge doesn't need a cause. Mass doesn't need a cause. And inertia, the resistance, to changing motion is part of what it means for matter to have mass at all. This is why the equations of motion don't ask why inertia exists. They simply describe how it behaves. If you apply a certain influence, the motion changes by a predictable amount. That predictability is the key. Inertia doesn't explain motion. It constrains it. It sets the rules for how motion can change. And once you see inertia this way, it stops being a mysterious obstacle. It becomes part of the structure that makes motion intelligible in the first place. Without inertia, motion would be chaotic. Objects would instantly jump from one state to another with no continuity. Inertia gives motion memory. It allows change to be smooth, proportional, and predictable, which brings us to a subtle but important realization. Inertia doesn't need a reason. It's one of the reasons motion behaves the way it does. This is the point where the question subtly changes. We stop asking, what causes inertia? And start asking, why we expect it to have a cause at all. In everyday thinking, resistance feels like something must be pushing back. A force, a mechanism, an interaction we haven't noticed yet. But inertia doesn't behave that way. It doesn't turn on or off. It doesn't depend on environment. It doesn't disappear when everything else is removed. It's simply there. In physics, this isn't unusual. Some features of reality are not explained by deeper causes. They are part of the foundation. Mass doesn't need a reason. Electric charge doesn't need a reason. They are properties that define how matter participates in the laws of physics. Inertia belongs in that same category. It tells us how motion responds to influence, not why motion exists in the first place. Once you accept this, something interesting happens. Motion no longer feels fragile. It doesn't require constant maintenance. It doesn't need an ongoing explanation. Change does. Acceleration does. But motion itself is simply what happens when nothing interferes. This flips the story we usually tell. Instead of seeing inertia as an obstacle to motion, we can see it as what gives motion continuity. It's what prevents sudden jumps, what allows smooth change, what makes prediction possible. Without inertia, the universe would not be easier to understand. It would be less stable. In that sense, inertia isn't a problem physics needs to solve. It's one of the reasons physics can work at all. So objects don't resist motion because something is pushing against them. They resist change because inertia is built into matter itself. Motion doesn't need to be created, maintained, or defended. It only needs a reason to change. And that reason is always external. A force, an interaction, a collision. Once the interaction ends, motion continues quietly, effortlessly. From this perspective, inertia isn't a flaw in how matter behaves. It's a feature. It gives motion stability. It makes change predictable. It allows the universe to evolve smoothly instead of jumping unpredictably from one state to another. So perhaps the deeper question isn't why objects resist motion. It's why we expect them not to. If inertia is simply part of what it means for matter to exist, then resistance to change isn't something to explain away. It's something to understand. And that leaves one final question. If inertia doesn't have a cause, what do you think it really represents? About the structure of physical reality? I'd love to hear your thoughts in the comments.